We'll look at a couple other graphing examples. And here, again, we have a rational function. We're factoring the levels. Factors of -8 to add to give you 2. Be positive 4 and -2. And we'll cancel quickly here to get x minus 2. Now, a couple of things here. Number one, this is something that we can graph without the aid of a graphing calculator. You've graphed this for years. It's just simply a line when you see x to the first power that's not enclosed in a special symbol like a square root or an absolute value. So I'm going to graph it as you've done in the past. Go down to -2, that's my y-intercept. Then I'm going to use the slope, which in this case is 1, to rise and run, up 1 over 1. Do it again here just to get some consistency. Now draw the graph. Remember, a graph is just a picture of all the solutions to a function. Now, what happens when I had a factor that gets canceled out, it's not a vertical asymptote. It ordinarily would be had it been on the bottom and not canceled out. But since this one canceled out, it's actually a hole in the graph. And what we do is set the canceled factor equal to 0, x plus 4 equals 0. And we know that -4 here is an excluded value because if I were to take -4 and plug it back in, it would make this an undefined function. But it's not a vertical asymptote here because it doesn't get very, very large or very, very small if you plug -4 into it, because that factor cancels out with another factor that was in the numerator. If I was to put -4 into this, you're simply going to get -6. So at -4, 4 over, it should line up with -6. My graph is not perfectly spaced, so it may not line up just right. What we do is just put a hole here. Okay? And that hole represents the fact that, again, it should be at -6 if I were to space this evenly. But this represents that this is not a solution. We'll make an open hole here to make that statement because -4 does not make this true. It makes it undefined. And as you approach -4 from either side, the value of the function does get closer and closer to -6, but can't actually equal -6 because it makes an undefined function here. So no asymptotes at all. It's just the hole in the graph. Now to list the other parts that we've talked about, we talked about zeros. Remember, zeros would be if I were to set the top equal to 0, and that still holds true here. If I was to set x minus 2 equal to 0, you're going to get 2, which is your x-intercept. You can see, since I've already graphed it, my y-intercept is -2. And that would be if you were to put zeros into everything. Remember, everything with x is going to go away, leaving -8 over 4. So my y-intercept is -2. No vertical asymptote, we've already mentioned that. No horizontal asymptote because the degree of the top is bigger than the degree of the bottom. As far as domain and range, domain are all values of x except the excluded values. So it would be all real, and this is a special symbol for all real numbers, except -4, because -4 is excluded. Now range, again, for range, there's no special trick. You just have to look at it. All y values covered by this graph. And this graph is going to go up forever, it's going to go down forever, but it cannot obtain the value -6 because that's where the x value is excluded, and that would be the value that you would get out. -4 minus 2 is -6. Again, the graph doesn't look like it's -6 because my spacing is not perfect. This would be all real numbers, except -6. Yeah, one more example here. This one requires no factoring, but is a little annoying because of this extra 4. It makes things where you have to think about how that 4 influences what goes where. Let's just go down the list here. First, we'll think about zeros. Now, zeros, remember, would be if I made f of x equals 0, and ordinarily that would be if I just set the top equal to 0. But here the top can equal 0, and I have this extra 4. So it makes the work a little bit more difficult. So we'll have 0 equals 1 over x minus 5 plus 4. Now I have to solve this. Now to solve it, you multiply everything, remember, by the LCD. The LCD here is x minus 5. So multiply everything by x minus 5. Such that those x minus 5's cancel. This is not too bad because 0 is going to take care of that for us. So we have 0 equals 1. 1's still there. And that 4 will distribute in here, plus 4x minus 20. Now I just want to solve this. That's going to be 0 equals 4x minus 19. I want to add the 19 over. My graph's going to get in the way here a little bit. We'll just go right over it here. 19 over 4 equals x. So my zeros, I'll make this a decimal. 4 will go into 16 4 times. This is 3 leftovers. This is going to be 4.75. So that is a singular 0. One of them. My 0 is 4.75. So I'll go ahead on my graph here. 1, 2, 3, 4, and then 3/4 of the way to 5. Put a dot. Now my y-intercept. Remember, anytime you hear the word intercept, there's a 0 involved somehow. This time the 0 is going to be where x is. All right. So let's erase my work here. For my y-intercept, I'm going to make x 0. So I'm going to have f of x, we can just write as a y. Y equals 1. This is going to be 0, so it's going to be 1 over negative 5 plus 4. So this is 20/5 minus 1/5. That's going to be 19 over 5. And 19 over 5 would be 3.8. I'm doing my math correctly. So this is 3.8. So on the y-axis, 1, 2, 3, and then almost the 4, but not quite. So now my graph is going to go through here somehow. A vertical asymptote. A vertical asymptote, remember, is just when the denominator equals 0. So we don't have to write this down. You can see the denominator is going to equal 0 when x is 5. Okay, so that's going to put a vertical asymptote. 1, 2, 3, 4, 5. That's right here. Right down through there. My horizontal asymptote, remember my horizontal asymptote, it was based on the situation. If the bottom degree was more than the top degree, here the bottom degree is 1 on the x and the top degree is 0, x to the 0 power. If that's the case, then this piece has a value of 0. Now we have this annoying 4 here, which is actually going to change our horizontal asymptote from 0, which it would be without the 4, to 4. Horizontal asymptote is 0 plus 4. So it's going to be at y equals 4. Again, the reason for that is the rules I wrote down was just for the fraction piece. And if you're adding a constant to it, whatever value you get here, you have to add that 4 to it. So y equals 4 is going to be right here. So we have this, and this is one of these where it's not easy to graph it unless you have a graphing utility, unless you or made an extensive table of values. And as I graph this one, what happens, you kind of get a sense of these after you've done a few. It's going to get very close right here, because we know it has to go through these 2 points. It's very close right here. Very, very, very close. Then it begins to dip down, and then it gets close to the vertical asymptote. And remember, you're never going to touch the vertical asymptote. Horizontal asymptotes are sometimes crossed. In this case, they're not, because you're leaving the page, so to speak. This is when the horizontal asymptote is not crossed. If this graph goes here, we really have no information about this, but what happens is there's another piece that does like this. Again, staying away from the asymptotes, like so. Your domain and range here, domain, remember, is easy. Just look at your excluded value. And this 4, by the way, does not change the fact that this is an excluded value, because I still can't have any denominator at a 0 regardless of what else is in there. My domain is all reals except 5. All reals except positive 5. Now range, in this case, and in some cases, will be all reals except for the horizontal aspect. That's not always true, but it is in this case. Range, you just kind of have to look at it. So all real numbers except 4. That's because the graph will never attain the y value 4.